Hydrogen is the simplest and most abundant element in the universe, with a single proton and a single electron. It is also one of the most essential elements for life on Earth, playing a crucial role in a wide range of biological and industrial processes. In this essay, we will explore the nature of hydrogen, its properties, and its applications in various aspects of life. The nature of hydrogen. Hydrogen is a chemical element with a symbol H and atomic number 1. The nature of hydrogen. Hydrogen is a chemical element with a symbol H and atomic number 1. It is a colorless, odorless, tasteless, and highly flammable gas at standard temperature and pressure. Hydrogen is also the lightest element in the periodic table, with an atomic weight of 1.008. It is composed of a single proton and a single electron, with no neutrons. Hydrogen is also the most abundant element in the universe, constituting around 75% of its elemental mass. Hydrogen is also the most abundant element in the universe, constituting around 75% of its elemental mass. It is formed through various processes, including nuclear fusion in stars, the Big Bang, and cosmic ray spallation. On Earth, hydrogen is mainly found in combination with other elements, such as water, H2O, and hydrocarbons, such as methane, CH4. On Earth, hydrogen is mainly found in combination with other elements, such as water, H2O, and hydrocarbons, such as methane, CH4. Properties of hydrogen. Hydrogen has several unique properties that make it useful for a variety of applications. Firstly, it is highly flammable and combustible, making it an excellent fuel source. When burned in the presence of oxygen, hydrogen produces a significant amount of energy, with water and heat as byproducts. When burned in the presence of oxygen, hydrogen produces a significant amount of energy, with water and heat as byproducts. This process, known as hydrogen combustion, is used in various industrial processes, including power generation, transportation, and heating. Secondly, hydrogen has a low density, making it useful in applications where weight is a critical factor. For example, it is used as a lifting gas in blimps and airships. However, due to the risk of fire and explosion, hydrogen is now mostly replaced by helium in these applications. Thirdly, hydrogen has a high thermal conductivity, making it useful in various cooling applications. It is also used in hydrogen fuel cells, where it reacts with oxygen to produce electricity and water. Applications of hydrogen in life. Hydrogen has many applications in various aspects of life, including energy production, transportation, and industry. In this section, we will explore some of the most significant applications of hydrogen. Hydrogen fuel cells. Hydrogen fuel cells are devices that convert hydrogen and oxygen into electricity, with water as a byproduct. They are an environmentally friendly and efficient alternative to traditional fossil fuels, producing only water and heat as byproducts. They are an environmentally friendly and efficient alternative to traditional fossil fuels, producing only water and heat as byproducts. Hydrogen fuel cells have several advantages over traditional fossil fuels. Firstly, they are cleaner and more environmentally friendly, producing no harmful emissions. Secondly, they are more efficient, converting around 60% of the energy in hydrogen into electricity, compared to only 20 to 30% for traditional internal combustion engines. Finally, hydrogen fuel cells are more versatile, with applications in various fields, including transportation, power generation, and industry. Transportation. Hydrogen is also used as a fuel for transportation, with various car manufacturers producing hydrogen fuel cell vehicles. These vehicles use hydrogen fuel cells to generate electricity, which powers electric motors. They produce no harmful emissions, making them a cleaner and more sustainable alternative to traditional fossil fuel vehicles. Hydrogen fuel cell vehicles have several advantages over traditional fossil fuel vehicles. Firstly, they are cleaner and produce no harmful emissions, making them better for the environment. Secondly, they are more efficient, using around 60% of the energy in hydrogen to power the vehicle, compared to only around 20 to 30% for traditional internal combustion engines. Secondly, they are more efficient, using around 60% of the energy in hydrogen to power the vehicle, compared to only around 20 to 30% for traditional internal combustion engines. Finally, hydrogen fuel cell vehicles have a longer range than electric vehicles, with some models capable of traveling up to 500 miles on a single tank of hydrogen. Industrial applications. Hydrogen is widely used in various industrial applications, including the production of chemicals, refining petroleum, and processing foods. It is also used in the production of ammonia, which is a key component of fertilizers. Hydrogen is also used in metal production, where it is used to reduce iron ore to iron in the process of steelmaking. This process, known as direct reduction, produces a high-purity form of iron, which is then used to produce various steel products. Energy storage. Hydrogen is also being explored as a potential energy storage solution, with the ability to store large amounts of energy in the form of hydrogen gas. This can then be used to generate electricity during periods of high demand or when renewable energy sources are not available. Hydrogen energy storage has several advantages over traditional battery storage. Firstly, hydrogen can store much more energy than batteries, making it a more practical solution for large-scale energy storage. Secondly, hydrogen can store much more energy than batteries, making it a more practical solution for large-scale energy storage. Secondly, hydrogen can be stored for long periods without losing its energy, making it more reliable than battery storage. Challenges in hydrogen application. Despite the numerous advantages of hydrogen, there are several challenges that need to be addressed for it to become a more widely used and practical solution. Despite the numerous advantages of hydrogen, there are several challenges that need to be addressed for it to become a more widely used and practical solution. These challenges include cost. One of the main challenges in the widespread adoption of hydrogen is its cost. Currently, hydrogen production is expensive, requiring significant energy input and infrastructure. This makes it less competitive compared to traditional fossil fuels, which have a more established infrastructure and lower production costs. This makes it less competitive compared to traditional fossil fuels, which have a more established infrastructure and lower production costs. Safety. Hydrogen is highly flammable and combustible, making it potentially dangerous if not handled properly. This poses a risk in the transportation and storage of hydrogen, as well as in its use in various applications. Infrastructure. Another challenge in the widespread adoption of hydrogen is the need for infrastructure. Currently, there is a limited infrastructure for hydrogen production, storage, and transportation, making it difficult to scale up the use of hydrogen.
Lithium is a soft, silvery white alkali metal with an atomic number of 3 and an atomic weight of 6.94. It is the lightest metal and the least dense solid element. Lithium is a highly reactive element, and it is not found in nature in its pure form, but rather as various salts and compounds. It has many unique properties that make it valuable in a wide range of applications. Lithium is commonly used in the production of batteries, particularly in rechargeable lithium-ion batteries. These batteries are widely used in portable electronic devices such as cell phones, laptops, and tablets. They are also used in electric vehicles and renewable energy storage systems. Lithium-ion batteries are preferred over traditional batteries because they have a higher energy density, longer lifespan, and are more environmentally friendly. The use of lithium in batteries has become increasingly important as the world transitions to renewable energy sources. Lithium-ion batteries are a key component in the storage of solar and wind energy. The use of renewable energy sources is essential to reducing greenhouse gas emissions and mitigating the effects of climate change. Lithium-ion batteries play a critical role in this transition, making it possible to store and use renewable energy when it is most needed. Lithium is also used in the production of ceramics and glass. It is added to glass to improve its durability and resistance to cracking. It is also used in the production of ceramics to increase their strength and reduce their weight. Lithium-based ceramics are used in a wide range of applications, including in electronic devices, aerospace, and defense industries. Another important use of lithium is in medicine. Lithium has been used for over 60 years to treat bipolar disorder. It is the most effective mood stabilizer available and is used to treat both acute manic episodes and as a long-term treatment to prevent relapse. Lithium works by changing the levels of certain chemicals in the brain, including serotonin and norepinephrine, which regulate mood and behavior. In addition to its use in the treatment of bipolar disorder, lithium is also being studied for its potential use in the treatment of other neurological disorders, including Alzheimer's disease and Parkinson's disease. Lithium has been shown to have neuroprotective effects, which means it can help protect the brain from damage and degeneration. While more research is needed in this area, lithium holds promise as a potential treatment for these devastating neurological conditions. Lithium is also used in the production of lubricants and greases. It is added to these products to reduce friction and wear, increase their resistance to high temperatures, and improve their overall performance. Lithium-based lubricants and greases are used in a wide range of applications, including in the automotive and aerospace industries. Another important use of lithium is in the production of alloys. Lithium is added to alloys to improve their strength, ductility, and resistance to corrosion. Lithium-based alloys are used in a wide range of applications, including in the aerospace and defense industries, as well as in the production of electronic components. Lithium is also used in nuclear power plants. Lithium-6 is used in the production of tritium, which is an important fuel for nuclear fusion reactions. Nuclear fusion is the process by which two atomic nuclei are combined to form a heavier nucleus, releasing a large amount of energy in the process. Lithium-6 is used as a neutron moderator in nuclear reactors, helping to control the rate of nuclear reactions and prevent runaway reactions. Despite its many valuable uses, the production and use of lithium can have negative environmental impacts. The mining of lithium can lead to deforestation, water pollution, and the destruction of wildlife habitats. The production of lithium-ion batteries also requires the extraction of other metals, such as cobalt and nickel, which can have their own environmental and social impacts. Additionally, the disposal of lithium-ion batteries can lead to the release of toxic chemicals into the environment. To address these concerns, efforts are underway to develop more sustainable and responsible practices for the production and use of lithium. This includes the use of more efficient mining techniques, the development of recycling programs for lithium-ion batteries, and the exploration of alternative materials for use in batteries and other applications. In conclusion, lithium is a valuable element with a wide range of applications in various industries, including batteries, ceramics and glass, medicine, lubricants, alloys, and nuclear power. Its unique properties make it essential for many technological advancements, particularly in the transition to renewable energy sources. However, its production and use can have negative environmental and social impacts, and efforts are needed to develop more sustainable and responsible practices. With continued research and innovation, lithium will continue to play a critical role in shaping the future of our world. One area where lithium is expected to play a particularly important role is in the transition to electric vehicles. As the world seeks to reduce its dependence on fossil fuels, electric vehicles are seen as a key part of the solution. However, the widespread adoption of electric vehicles is dependent on the availability of efficient and affordable lithium-ion batteries. The production of electric vehicles is expected to increase dramatically in the coming years, and this is driving a surge in demand for lithium. According to the International Energy Agency, the demand for lithium is projected to increase by 40 times its current level by 2040 to meet the needs of the electric vehicle market. This presents both challenges and opportunities for the lithium industry. One challenge is the need to increase the supply of lithium to meet the growing demand. The majority of the world's lithium reserves are located in a small number of countries, including Chile, Argentina, Australia, and China. This concentration of resources presents a potential geopolitical risk, as countries seek to secure their access to lithium. Another challenge is the need to reduce the environmental impact of lithium mining and production. The mining of lithium can have negative impacts on local communities and ecosystems, including water scarcity, pollution, and deforestation. Additionally, the production of lithium-ion batteries requires the extraction of other metals, such as cobalt and nickel, which can have their own environmental and social impacts. To address these challenges, efforts are underway to develop more sustainable and responsible practices for the production and use of lithium. This includes the use of more efficient mining techniques, the development of recycling programs for lithium-ion batteries, and the exploration of alternative materials for use in batteries and other applications.
Helium is a chemical element with a symbol He and atomic number 2. It is the second lightest element in the periodic table and is the second most abundant element in the universe, after hydrogen. Helium is a colorless, odorless, tasteless, and non-toxic gas that is chemically inert. It was first discovered in 1868 by French astronomer Jules Janssen during a solar eclipse. Since then, it has become an important element for many applications in various fields of science and technology. In this essay, we will discuss the properties of helium and its applications in life. Properties of helium. Helium is a noble gas, which means it is unreactive and does not readily combine with other elements. It is also the only element that cannot be solidified by lowering the temperature alone. Helium has a boiling point of -452.07 degrees Fahrenheit, -268.93 degrees Celsius, and a melting point of -457.96 degrees Fahrenheit, -272.20 degrees Celsius, at standard pressure. Its density is approximately 1/7 that of air, which makes it lighter than air, and it has the lowest boiling point of any element. Helium is present in the atmosphere at a concentration of only 5.24 parts per million, ppm, by volume. However, it is much more abundant in the universe, where it is formed through nuclear fusion in stars. Helium is also present in natural gas deposits, where it is extracted by liquefaction. Applications of helium. Balloons. One of the most well-known applications of helium is in balloons. Helium balloons are a popular decoration for parties and events, and they have become a symbol of celebration. The low density of helium makes it ideal for use in balloons because it makes them buoyant. Helium-filled balloons can float in the air for days or even weeks, depending on the size and quality of the balloon. Helium is also used in blimps and airships for the same reason. Medical imaging. Helium is used in medical imaging to cool the magnets in magnetic resonance imaging, MRI, machines. MRI machines use strong magnetic fields to produce detailed images of the inside of the body. The magnets in these machines need to be cooled to extremely low temperatures to maintain their superconductivity, and helium is the most effective coolant for this purpose. Welding. Helium is also used as a shielding gas in welding. When welding, a gas is used to shield the weld from the surrounding air, which can contaminate the weld and cause defects. Helium is often used for this purpose because it is inert and does not react with the metal being welded. It also has a high thermal conductivity, which means it can transfer heat away from the weld quickly, preventing it from overheating. Deep-sea diving. Helium is used in deep-sea diving to prevent a condition known as the bends. When divers ascend too quickly from deep water, the pressure decreases rapidly, causing nitrogen gas to form bubbles in the bloodstream. This can lead to serious health problems, including paralysis and death. Helium is used in breathing gas mixtures for deep-sea diving because it is less soluble in blood than nitrogen, reducing the risk of the bends. Cryogenics. Helium is also used in cryogenics, the science of extremely low temperatures. Helium is the most common coolant used in cryogenic applications because it has the lowest boiling point of any element. It is used to cool superconducting magnets, which are used in a wide range of applications, including particle accelerators and nuclear magnetic resonance, NMR, spectroscopy. Gas chromatography. Helium is also used as a carrier gas in gas chromatography, a common analytical technique used in chemistry and biology. Gas chromatography separates and analyzes complex mixtures of substances by passing them through a column filled with a stationary phase, which separates the mixture based on its physical and chemical properties. Helium is the most commonly used carrier gas in gas chromatography because it is inert and does not react with the sample being analyzed. Lighting. Helium is used in lighting applications, including neon signs and high-intensity discharge (HID) lamps. HID lamps are used in street lighting, stadium lighting, and other applications where high-intensity light is required. Helium is used in these lamps to prevent tungsten from evaporating from the filament, which can cause the lamp to fail prematurely. Cooling systems. Helium is used as a coolant in some high-performance cooling systems, such as those used in nuclear power plants and particle accelerators. Helium has a high thermal conductivity, which means it can transfer heat away from a system quickly, making it an effective coolant. It is also non-reactive, which makes it an ideal choice for cooling systems that use corrosive fluids or gases. Space exploration. Helium is also used in space exploration. Helium is used as a fuel for some rockets, and it is also used in gas chromatography to analyze samples collected during space missions. Helium is also used in cooling systems for spacecraft and satellites. Breathing gas mixtures. Helium is used in breathing gas mixtures for divers, astronauts, and pilots. These mixtures, known as trimix or heliox, are used to reduce the risk of decompression sickness and other health problems associated with breathing air at high pressures. Helium is used in these mixtures because it is less soluble in blood than nitrogen or oxygen, reducing the risk of the bends and other health problems. Conclusion. In conclusion, helium is a chemical element with unique properties that make it useful for a wide range of applications. Helium is used in balloons, medical imaging, welding, deep-sea diving, cryogenics, gas chromatography, lighting, cooling systems, space exploration, and breathing gas mixtures. Its low density, high thermal conductivity, and inertness make it an ideal choice for many of these applications. Although helium is abundant in the universe, it is relatively rare on Earth, and its supply is limited. As a result, it is important to use helium wisely and to develop alternative technologies that reduce our dependence on this valuable resource. The importance of helium cannot be overstated, as it has become an essential component in modern technology and industry. However, its availability is limited and therefore, efficient use of this resource is crucial. It is important for industries and research institutions to work towards the development of new technologies that can use alternative resources to reduce the demand for helium. Moreover, government policies should be put in place to regulate the use of helium and encourage sustainable practices that conserve this resource. Beryllium is a metallic element with atomic number 4 and symbol B. It is a rare metal that belongs to the alkaline earth metals family. Beryllium is a lightweight and strong metal that has unique properties that make it useful in various industrial applications. Beryllium is a lightweight and strong metal that has unique properties that make it useful in various industrial applications. In this essay, we will discuss the element beryllium, its physical and chemical properties, its occurrence, extraction, and uses in everyday life. Properties of beryllium. Beryllium is a relatively small atom with a radius of 1.12 A ring. It has 2 valence electrons, and its electronic configuration is He2s2. Beryllium has a melting point of 1287 degrees Celsius and a boiling point of 2471 degrees Celsius. It is a lightweight metal, with a density of 1.85 grams/cm3. Beryllium is also a very hard and strong metal, with a tensile strength of up to 345 MPa, which makes it one of the strongest metals known. Beryllium is also a very hard and strong metal, with a tensile strength of up to 345 MPa, which makes it one of the strongest metals known. Beryllium is a good conductor of heat and electricity, and it is also transparent to X-rays. Occurrence of beryllium. Beryllium is a relatively rare element in the Earth's crust, with a concentration of only 2 to 6 parts per million. It is mainly found in minerals such as beryl, which is a beryllium aluminum cyclosilicate, and bertrandite, which is a beryllium silicate. Beryl is the most common mineral that contains beryllium, and it is found in various parts of the world, including Brazil, Russia, the United States, Madagascar, and Colombia. Bertrandite, on the other hand, is found in the United States, China, and Kazakhstan. Extraction of beryllium. Beryllium is a relatively difficult metal to extract due to its high reactivity with oxygen and other elements. Beryllium is a relatively difficult metal to extract due to its high reactivity with oxygen and other elements. The most common method used to extract beryllium is through a process known as the beryllium extraction process. In this process, beryl or bertrandite minerals are first crushed and then treated with sulfuric acid to form a beryllium sulfate solution. The beryllium sulfate solution is then treated with ammonia to form ammonium beryllium sulfate, which is then heated to form beryllium oxide. The beryllium sulfate solution is then treated with ammonia to form ammonium beryllium sulfate, which is then heated to form beryllium oxide. The beryllium oxide is then reduced with magnesium to form beryllium metal. Applications of beryllium. Beryllium has a wide range of applications in various industries due to its unique properties. Some of the applications of beryllium are discussed below. Aerospace industry. Beryllium is widely used in the aerospace industry due to its lightweight and strong properties. Beryllium is used to make various aerospace components, including satellite structural components, rocket nozzles, and high-speed aircraft parts. Beryllium is also used in the manufacturing of guidance systems, gyroscopes, and other electronic components used in aerospace applications. Nuclear industry. Beryllium is widely used in the nuclear industry due to its high thermal conductivity and transparency to X-rays. Beryllium is used in the manufacturing of nuclear reactors, where it is used as a neutron reflector and moderator. Beryllium is also used as a target material for particle accelerators. Medical industry. Beryllium is used in the medical industry due to its transparency to X-rays. Beryllium is used in the manufacturing of X-ray windows, which are used to allow X-rays to pass through while blocking out other forms of radiation. Beryllium is also used in the manufacturing of dental and medical implants due to its biocompatibility with human tissue. Additionally, beryllium is used in radiation therapy equipment and in the production of isotopes for medical imaging. Electronics industry. Beryllium is widely used in the electronics industry due to its high electrical conductivity and low density. Beryllium is used in the manufacturing of electrical contacts, connectors, and switches. Beryllium is also used in the manufacturing of computer components, such as heat sinks, which help to dissipate heat from electronic components. Beryllium is also used in the manufacturing of computer components, such as heat sinks, which help to dissipate heat from electronic components. Defense industry. Beryllium is used in the defense industry due to its lightweight and strong properties. Beryllium is used to make various military components, including missile nose cones, armor plates, and submarine hulls. Beryllium is also used in the manufacturing of detonators and explosives due to its high reactivity with other elements. Automotive industry. Beryllium is used in the automotive industry due to its lightweight and strong properties. Beryllium is used to make various automotive components, including brake components, steering components, and suspension components. Beryllium is also used in the manufacturing of engine components, such as valves and pistons, due to its high melting point and low thermal expansion coefficient. Sports equipment. Beryllium is used in the manufacturing of sports equipment due to its lightweight and strong properties. Beryllium is used to make various sports equipment components, including bicycle frames, golf club heads, and tennis rackets. Safety concerns. Beryllium is a highly toxic metal, and exposure to beryllium can cause a range of health problems. Beryllium is a highly toxic metal, and exposure to beryllium can cause a range of health problems. Beryllium is classified as a human carcinogen, and exposure to beryllium can cause lung cancer. Beryllium exposure can also cause a range of respiratory problems, including chronic bronchitis and emphysema. Additionally, exposure to beryllium can cause skin irritation and allergic reactions. Conclusion. Beryllium is a unique and versatile metal that has a wide range of applications in various industries. Beryllium is a unique and versatile metal that has a wide range of applications in various industries. Beryllium is used in the aerospace, nuclear, medical, electronics, defense, automotive, and sports equipment industries due to its lightweight and strong properties.
Carbon is one of the most abundant elements on Earth and is essential for life. It is a nonmetallic element with the atomic number 6 and symbol C. Carbon is known for its unique ability to form complex organic molecules, which are the building blocks of life. Carbon is found in all living things and plays a crucial role in many biological processes. In this essay, we will explore what carbon is and its application in life. Carbon is a chemical element that occurs naturally in the Earth's crust, in the form of minerals such as graphite and diamond. Carbon is also present in the atmosphere, as carbon dioxide, CO2, which is a greenhouse gas. It is an essential element for life because it is the basic building block of all organic molecules. Organic molecules are molecules that contain carbon and are the basis of all living organisms. One of the unique properties of carbon is its ability to form covalent bonds with other atoms, which allows it to form a wide range of compounds. These compounds include hydrocarbons, carbohydrates, lipids, proteins, and nucleic acids, which are essential for life. Carbon is also able to form double and triple bonds with other atoms, which increases the diversity of organic molecules that can be formed. The applications of carbon in life are numerous and can be seen in many aspects of biology, chemistry, and industry. One of the most important applications of carbon is its role in the carbon cycle, which is the process by which carbon is exchanged between the atmosphere, oceans, and living organisms. The carbon cycle is a complex process that involves the absorption of carbon dioxide by plants during photosynthesis, the release of carbon dioxide by animals during respiration, and the decay of organic matter by decomposers. Carbon is also an essential component of fossil fuels, such as coal, oil, and natural gas. These fuels are formed from the remains of ancient plants and animals that were buried and subjected to heat and pressure over millions of years. Fossil fuels are a major source of energy for modern society, but their use has been linked to climate change due to the release of carbon dioxide during combustion. In addition to its role in the carbon cycle and fossil fuels, carbon has many other applications in daily life. One of the most well-known applications of carbon is its use in pencils. Graphite, a form of carbon, is used to make the lead in pencils. Graphite is a soft, black mineral that is easily broken into thin sheets or flakes, which makes it ideal for writing. Carbon is also used in the manufacture of a wide range of materials, including plastics, rubber, and textiles. Many of these materials are made from synthetic polymers, which are long chains of repeating units. These polymers are made by combining small molecules called monomers, which often contain carbon. By varying the type and number of monomers used, it is possible to create a wide range of synthetic polymers with different properties. Carbon is also an important component of many medications and drugs. Many drugs are organic compounds that contain carbon and other elements. For example, aspirin is made from salicylic acid, which is a naturally occurring compound found in plants. The carbon atoms in salicylic acid are essential for its biological activity. Carbon is also used in the field of nanotechnology, which involves the manipulation of materials at the atomic and molecular scale. Carbon nanotubes, for example, are cylindrical structures made from carbon atoms that are just one atom thick. Carbon nanotubes have unique properties, such as high strength and electrical conductivity, which make them useful in a wide range of applications, including electronics and energy storage. In conclusion, carbon is an essential element for life and has numerous applications in daily life. Its ability to form covalent bonds with other atoms allows it to form a wide range of compounds that are essential for biological processes. Carbon is also a key component of many materials, including plastics, rubber, and textiles. Its role in the carbon cycle and the production of fossil fuels has significant implications for the environment and climate change. While carbon has many beneficial applications in daily life, its impact on the environment and climate change cannot be ignored. The burning of fossil fuels releases large amounts of carbon dioxide into the atmosphere, which contributes to the greenhouse effect and global warming. The increased use of carbon-based materials, such as plastics, has also led to a significant increase in pollution and environmental degradation. Efforts are being made to reduce the impact of carbon on the environment and climate change. These efforts include the development of renewable energy sources, such as solar and wind power, which do not rely on fossil fuels. The use of carbon capture and storage technology, which involves capturing carbon dioxide from industrial processes and storing it underground, is also being explored as a way to reduce carbon emissions. In conclusion, carbon is an essential element for life and has many applications in daily life, from the production of plastics and drugs to the carbon cycle and energy production. Its unique ability to form covalent bonds with other atoms allows it to form a wide range of compounds that are essential for biological processes. However, its impact on the environment and climate change cannot be ignored, and efforts must be made to reduce its use and emissions. Additionally, the use of carbon-based materials, such as plastics, has led to significant environmental problems, such as pollution and the accumulation of waste. Plastics, which are made from petroleum, do not biodegrade and can persist in the environment for hundreds of years. The accumulation of plastic waste in oceans and waterways has become a significant problem, threatening marine life and ecosystems. Efforts to reduce the impact of carbon on the environment and climate change have also led to the development of new technologies and innovations. For example, researchers are exploring the use of biofuels, which are made from organic materials such as corn and sugarcane, as a renewable alternative to fossil fuels. Biofuels can be produced in a sustainable manner, reducing greenhouse gas emissions and dependence on fossil fuels. Carbon capture and storage technology is another promising solution for reducing carbon emissions. This technology involves capturing carbon dioxide from industrial processes, such as power plants, and storing it underground in geological formations. Carbon capture and storage has the potential to reduce carbon emissions by up to 90%, making it a promising solution for reducing the impact of carbon on the environment. In the field of nanotechnology, carbon has also played an important role. Carbon nanotubes, for example, are being developed as a potential solution for energy storage. Carbon nanotubes have a high surface area and can store large amounts of energy, making them a promising solution for the development of high-capacity batteries and energy storage devices. In the field of medicine, carbon is also playing an increasingly important role. Nitrogen is a chemical element with the symbol N and atomic number 7. It is a non-metal and constitutes approximately 78% of Earth's atmosphere. Nitrogen is essential to all forms of life, as it is a major component of amino acids, nucleic acids, and other biomolecules. It is also used in a variety of industrial and agricultural applications. In this essay, we will explore the properties and applications of nitrogen in both biological and non-biological contexts. Properties of nitrogen. Nitrogen is a colorless, odorless, tasteless gas that is relatively inert at room temperature and pressure. It is the most abundant element in Earth's atmosphere, making up about 78% of the air we breathe. Nitrogen gas is denser than air, and it is slightly soluble in water. It can be liquefied at very low temperatures and pressures, and it boils at a temperature of -196 degrees Celsius. Nitrogen gas is not toxic, but it can displace oxygen in closed spaces and cause asphyxiation. Nitrogen is a diatomic molecule, which means that it consists of two nitrogen atoms bonded together. The nitrogen molecule has a triple bond, which is one of the strongest covalent bonds in nature. This triple bond makes it difficult for nitrogen gas to react with other substances, which is why it is relatively inert. However, under certain conditions, nitrogen can react with other elements to form a wide range of compounds. Biological applications of nitrogen. Nitrogen is an essential element for all forms of life. It is a major component of amino acids, which are the building blocks of proteins. Proteins are essential for cell structure and function, as well as for the regulation of metabolic pathways. Nitrogen is also a component of nucleic acids, which are the genetic material of cells. Nucleic acids, such as DNA and RNA, contain nitrogen in the form of nucleotides, which are the monomers that make up these polymers. In order for organisms to utilize nitrogen in the form of amino acids and nucleotides, it must be converted into a biologically available form. This process is called nitrogen fixation, and it can be carried out by a variety of organisms, including bacteria, fungi, and plants. Some bacteria, such as Rhizobium, form symbiotic relationships with legume plants and convert atmospheric nitrogen into ammonia, which is then used by the plant to make amino acids and other nitrogen-containing compounds. Other bacteria, such as Azotobacter, are free-living and can fix nitrogen in the soil. Fungi can also form symbiotic relationships with plants, and some species can fix nitrogen as well. Plants can also fix nitrogen, although they do so in a different way. Some plants, such as soybeans and alfalfa, have nodules on their roots that contain bacteria capable of nitrogen fixation. Other plants, such as clover and peas, have root systems that can trap nitrogen from the air and convert it into a form that can be used by the plant. Nitrogen fixation is essential for maintaining soil fertility, as it replenishes the nitrogen that is lost through plant growth and other processes. Nitrogen is also an important component of the Earth's nitrogen cycle. The nitrogen cycle describes the movement of nitrogen through the environment, as it is cycled between living organisms, the atmosphere, and the soil. Nitrogen is taken up by plants and incorporated into their tissues, which are then consumed by animals. When these organisms die or excrete waste, nitrogen is returned to the soil, where it can be taken up by plants again. Bacteria and fungi play a key role in this cycle, as they break down organic matter and convert nitrogen into different forms that can be used by plants and other organisms. Non-biological applications of nitrogen. In addition to its biological applications, nitrogen has a wide range of industrial and commercial uses. One of the most common uses of nitrogen is in the production of ammonia, which is used to make fertilizer. Nitrogen gas can be combined with hydrogen gas under high pressure and temperature to form ammonia, which is then used to make nitrogen-rich fertilizers that are essential for crop production. Without nitrogen fertilizer, it would be much more difficult to produce enough food to feed the world's growing population. Nitrogen is also used in a variety of other industrial applications. For example, it is used in the production of semiconductors, where it is used to create a controlled atmosphere that is free of oxygen and other impurities. Nitrogen gas is also used to purge and pressurize pipelines, tanks, and other equipment, as it is inert and does not react with other substances. This makes it ideal for use in industries such as oil and gas, where safety is a major concern. Another important use of nitrogen is in the food and beverage industry. Nitrogen gas is used to preserve the freshness and flavor of packaged foods and beverages. It is also used to create a frothy, creamy head on beers and other carbonated drinks. In the healthcare industry, nitrogen is used to freeze and preserve biological samples, such as sperm and embryos. Nitrogen gas is also used in the aerospace industry. Liquid nitrogen is used to cool rocket engines and other components that need to be kept at extremely low temperatures. It is also used to create an inert atmosphere inside the fuel tanks of rockets and other spacecraft. Conclusion. In conclusion, nitrogen is a versatile and essential element that plays a vital role in both biological and non-biological systems. It is a major component of amino acids, nucleic acids, and other biomolecules that are essential for life. Nitrogen fixation by bacteria, fungi, and plants is crucial for maintaining soil fertility and supporting crop production. Nitrogen is also used in a wide range of industrial and commercial applications, including the production of fertilizer, semiconductor manufacturing, food preservation, and rocket propulsion. Despite its abundance, nitrogen is not always readily available in a form that is usable by organisms, and its conversion into biologically available forms is a complex and important process. Overall, nitrogen is a fascinating and important element that has a wide range of applications in our daily lives. Future perspectives. As the world's population continues to grow and demand for food and other resources increases, there is a growing need for sustainable methods of nitrogen fixation and fertilizer production. Currently, the Haber-Bosch process is the primary method for producing ammonia for fertilizer, but it is energy intensive and requires large amounts of fossil fuels. There is ongoing research into alternative methods of nitrogen fixation, such as biological nitrogen fixation using bacteria, as well as new processes for producing ammonia that are more energy efficient and environmentally friendly. Oxygen is one of the most vital elements in the universe. It is essential for life, and its role cannot be understated. Oxygen is a colorless, odorless, and tasteless gas that is found in the atmosphere, and it constitutes about 21% of the air we breathe. This element is essential for the survival of all living organisms, from the smallest bacteria to the most complex animals. In this essay, we will explore what oxygen is, its properties, and its various applications in life. What is oxygen? Oxygen is a chemical element with the symbol O and atomic number 8. It is a member of the chalcogen group on the periodic table, a highly reactive nonmetal, and an oxidizing agent that readily forms oxides with most elements as well as with other compounds. By mass, oxygen is the third most abundant element in the universe, after hydrogen and helium. At standard temperature and pressure, two atoms of the element bind to form dioxygen, a colorless and odorless diatomic gas with the formula O2. Properties of oxygen. Oxygen is a highly reactive element, and its chemical properties make it a vital component of life. Oxygen is a colorless gas that is slightly denser than air. It is highly soluble in water, and it supports combustion. When oxygen combines with other elements, it produces oxides. Oxygen is a highly reactive element, and it can combine with almost all the other elements in the periodic table. Oxygen is a highly electronegative element, meaning that it can attract electrons from other elements. This property makes it an excellent oxidizing agent. When oxygen reacts with other elements, it forms oxides. Oxides are chemical compounds that contain oxygen and another element. For example, carbon dioxide, CO2, is an oxide of carbon. Oxygen's role in life. Oxygen plays a critical role in life. It is essential for the survival of all living organisms, from the smallest bacteria to the most complex animals. In humans, oxygen is necessary for respiration. Respiration is the process by which the body converts food into energy. Oxygen is required for this process to occur. When we breathe in air, oxygen is absorbed into our lungs and transported to the cells in our body. In the cells, oxygen reacts with glucose, a simple sugar, to produce energy. The waste products of this process are carbon dioxide and water. The carbon dioxide is transported back to the lungs, where it is exhaled. Oxygen is also critical for the functioning of the brain. The brain consumes about 20% of the body's oxygen. When the brain does not receive enough oxygen, it can lead to a condition called hypoxia. Hypoxia can cause dizziness, confusion, and even unconsciousness. Oxygen is also used by the body's immune system to fight off infections. The white blood cells in the body use oxygen to produce reactive oxygen species, RAS, which are toxic to bacteria and other pathogens. Oxygen in industry. Oxygen is not just essential for life, it also has numerous applications in industry. One of the most important uses of oxygen in industry is in the production of steel. Oxygen is used to blow air into molten iron, which burns off impurities and produces steel. This process, known as the Bessemer process, revolutionized the steel industry and made mass production of steel possible. Oxygen is also used in the production of chemicals. Many chemical reactions require oxygen to occur. For example, the production of ethylene oxide, which is used to produce plastics, requires oxygen. Oxygen is also used in the medical industry. Oxygen is used to treat patients with respiratory problems. Patients with conditions such as emphysema or asthma may require supplemental oxygen to breathe properly. Oxygen is also used during surgeries to help patients breathe and maintain their oxygen levels. Oxygen is also used in the aerospace industry. It is used to provide breathable air for astronauts in space. Oxygen is also used in rockets and missiles to help fuel combustion and increase their efficiency. Oxygen in the environment. Oxygen plays a critical role in the environment. Plants use oxygen during photosynthesis to produce energy. During photosynthesis, plants use carbon dioxide and water to produce glucose and oxygen. The oxygen produced during photosynthesis is then released into the atmosphere, where it is used by animals and other organisms. Oxygen is also essential for the health of aquatic ecosystems. Fish and other aquatic organisms require oxygen to breathe. In areas where the oxygen levels are low, aquatic life can suffer, and fish kills can occur,